So in this topic we are going to discuss about the ways of measuring water quality and how water quality can be measured. So let us start with DOM monitoring, which is dissolved organic matter monitoring. Colored or chromophobic dissolved organic matter occurs naturally in water bodies. This organic matter absorbs the ultraviolet light and decomposes to release tannin, an organic pollutant that causes the water to turn murky. Moreover, tannin contributes to reducing the pH of the water and depleting the oxygen levels. A portion of the CDOM fluoresces and is referred to as fluorescent dissolved organic matter, further making the water look cloudy. So, a portion of the CDOM fluoresces and is referred to as fluorescent dissolved organic matter, which make the water look more cloudy. So these CDOM or FDOM levels can be measured by using electrical optical sensors that uses fluorometers and sapphire lens. So the electrical optical sensors use fluorometers and sapphire lens. These sensors gauge the light availability in water bodies depending on the water level and indicate the concentration of dissolved organic matter. So in this way, dissolved organic matter monitoring is done. Now we will discuss about chlorophyll fluorescence analysis. So what is that? So when the surface water in ponds and lakes is rich in minerals, namely phosphorus and nitrogen, algae flourish. So when the lakes and ponds are rich in minerals, namely phosphorus and nitrogen, algae flourishes in it. Disproportionate growth of algae leads to oxygen depletion and increased level of nitrogen and phosphorus, which can be toxic to the flora and fauna. So this increased level of nitrogen and phosphorus can be toxic to the flora and fauna. Chlorophyll fluorescence measured using algae toximeters indicates the percentage of chemical chlorophyll and active chlorophyll in water sample under illumination. This is an effective method to keep a check on the excessive algal growth and monitor the water quality. The next one is TDS monitoring. TDS stands for total dissolved solids. So the conductivity of a water body is an early indicator of the water quality. Conductivity affects the salinity and total dissolved solids content, which in turn affects the concentration of oxygen in the water. So the conductivity of the water body can be an indicator of the water quality. Certain ecological and man-made factors can increase or decrease the water body's conductivity, severely impacting the water quality. For example, an oil spill or increased levels of organic substances in an ocean can decrease its conductivity, indicating water pollution. So conductivity, salinity and TDS meters analyze the water quality by measuring the specific electrical conductance of electrolytes dissolved in the water. Though each of these instruments measure a separate parameter, the results are correlated and indicative of pollution. The next one is pH testing. An increasing pH level is dangerous to the ecosystem of the water body. A safe pH range for a pond or lake is between 6.0 to 8.0. pH can be tested using water test kits that are color coded and offer a wide range of pH measurement. So the next way is recording the water temperature. Temperature is a crucial factor that affects the other water quality parameters such as the rate of photosynthesis and metabolism, the dissolved gas concentrations, conductivity and salinity, the pH and the water density, among other factors. For example, ammonia at a high pH is toxic to plants and aquatic animals. However, a sudden change in temperature can double the impact. The next way is measuring the dissolved oxygen levels. The dissolved oxygen is a measure of the amount of oxygen available to the flora and fauna and is reported as % saturation or milligram per liter. The oxygen levels in water go down owing to the decomposition of organic materials such as dead plant and animals and human wastage. A dissolved oxygen level of less than 6 mg per liter can be harmful to the ecosystem of water bodies. The dissolved oxygen concentration can be measured using the electrochemical or optical sensor, the colorimetric method, the Winkler titration method, and the optical dissolved oxygen sensors. And the last way is the assessing the turbidity, TSS, and clarity. So the solar radiation provides light, heat, and energy to all living beings on Earth. Low or high levels of ultraviolet radiations can halt the photosynthetic process, causing permanent damage to the aquatic ecosystem. Suspended solids, decaying vegetation, and other dissolved colored materials cause the water to appear cloudy and murky, impacting the penetration of sunlight on water and the aquatic life. A sudden increase in the turbidity and the total suspended solids is an indicator of soil erosion and point source pollution, adding heavy metals and effluents into the water. So a sudden increase in the turbidity and the total suspended solids is an indicator of what? Is an indicator of soil erosion and point source pollution, adding heavy metals and effluents into the water. A nephelometer is used to measure the scattered light at an angle of 90 degrees, and the results are reported in nephelometric turbidity unit. The total suspended solids are measured by filtering and weighing the sample and are measured in milligrams of solids per liter of water. So with this, the topic ways of measuring water quality comes to an end. Let me take a recap of what I have discussed in this topic. We have discussed about DOM monitoring, chlorophyll fluorescence analysis, Tds monitoring, pH testing, recording the water temperature, measuring the dissolved oxygen levels, and assessing the turbidity, TSS, and clarity. Now with this, I am ending my topic.